We're going to look at a few more examples involving simplifying square roots. We're going to look at number 14. Sometimes we do have a negative out front or a negative one, and that just means that our answer is going to have a negative. Then we just factor tree. We don't include the negative here because it is basically saying take the opposite of whatever we get from simplifying the square root of 48. Previously, we said that 16 times 3 seemed to be a good choice. And if you do it other ways, you'll probably come to realize that this would be more efficient. Out comes the 4. Square root of 16 is 4, and the 3 will stay. We're going to look at a couple other ones. I'm not going to do 15, but it is important to note that because both of these are perfect squares, I would not simplify this fraction. Although you can do that at times, that is not something that you want to do because it might cause you to not be able to simplify or remove the square root in the denominator. So just watch out for that. Sometimes it's best to cancel the fraction, and other times it's best to just square root each part. I'm not going to do that one. I like to look at 17 though. And 17 with decimals, 12 is not a perfect square. And so 12 hundredths probably can't use the trick that we've been using. So the other trick that we're going to use is that we're going to change this into a fraction. And not to mention that usually a decimal with square roots is not a good idea. You're not going to have a simplified answer unless it just so happens to be one of those problems like 6-1a. And from here now, we can square root each part. Technically, I could simplify this, like I was mentioning on problem number 15. But that's not going to be good because 50 isn't a perfect square. So this way is actually the best because we get then 10 here, works out nice, and then we can simplify square root of 12. And 12 does not seem to have much inside of it, but it actually does. And there's lots of factor choices for 12, but this one seems to work best. Ooh, and we get something else here, which is that previously we said that this is the same 2/10 times root 3 or 2 root 3 over 10, which means that thinking back to this, we could have simplified 2/10, either written like this or like this. This would become a 1, and this one would become a 5, just like this would become a 1, and this would be a 5. So, make a long story short, we have then root 3 over 5, or 1/5 root 3. And notice how there is not a square root in the denominator. So that is a good sign.